We all rise together, back to the moon and beyond, why the Artemis program matters.
We choose to go to the moon. We choose to go to the moon. We choose to go to the moon in this decade and do the other things, not because they are easy, but because they are hard. Because that goal will serve to organize and measure the best of our energies and skills.
The moon has long captured human imagination. In most Western languages, the moon is called Luna, and it's the closest celestial being to the Earth. And every month, it brightly reflects on humanity. Most cultures on Earth have organized their calendar system on 1. The orbit around the Sun, and 2. The orbit of the moon around the Earth. Since long ago, famous novels have described fantastic voyages to the moon. Jules Vern, From the Earth to the Moon, shows how deeply the moon has always captured human imagination. So how would one get to the moon? The answer would be rocketry. Rocketry is a discipline or science that develops or studies rockets. A rocket is a vehicle that uses jet propulsion but without relying on wings or lift, contrary to fixed-wing or rotary-wing aircrafts. Rocket produces thrust through a chemical reaction, through very quickly expelling large volumes of hot gas, expelled as exhaust at high speeds. Rockets can fly in the vacuum of space. In fact, they are more efficient in space. Rockets on Earth have to fight against the Earth's atmosphere to move, which there isn't in vacuum of space. On Earth, they actually lose thrust due to the opposing pressure of the atmosphere. Multistage rockets are capable of achieving escape velocity from the Earth, and therefore have achieved a theoretical infinite maximum altitude. Chemical rockets are the most common type of high-powered rockets, usually creating thrust or exhaust by the combustion of a fuel and an oxidizer that creates a violent chemical reaction that expands extremely quickly. So rockets can store a large amount of chemical energy that they can easily release. Chemical rockets often mix propellants such as liquid hydrogen or kerosene with an oxidizer, such as liquid oxygen or nitric acid, to produce very large volumes of hot gas.
Both the first and second stages are powered by spaceX Merlin engines. The Merlin engine is powered by liquid fuel and oxidizer. Both of them burn together and generate thrust. During the first stage, the Merlin engine's powered by liquid fuel and liquid oxidizer. Both fuel and oxidizer are partially mixed with each other, and the combustion takes place. The first stage having 9 Merlin engines. Each of them generates 845 kilonewtons of thrust and 981 kilonewtons of thrust in vacuum.
Rocketry has found an extremely wide variety of uses in research, defense, commerce, and aeronautics. Rocketry has had an immense impact on the modern technological world, from the rockets used to put communications and GPS global positioning satellite constellations into orbit, and also instrumentation like the Hubble and the recently launched James Webb Space Telescope that we need to peer off into the galaxy and explore the universe, or SpaceX's reusable Falcon rockets used to refuel the International Space Station, so the geopolitics of mutually assured destruction, and intercontinental ballistic missiles. You could easily make the argument that the availability of numerous and sophisticated rocketry systems is a defining factor in Russia's inhumane invasion of Ukraine. Fortunately, the arsenal of democracy is vast. The mastery of rocketry is a hallmark of a great or superpower, and nations around the world use rocketry as a way to establish dominance over each other. And fear of falling behind was a major factor in the Cold War and the space race. All this is more so given that rocketry is the best way to deliver a nuclear weapon. More so is rocketry important because there's a lot of overlap in the technologies used to launch satellites as used to launch nuclear weapons into ballistic trajectory in orbit.
Strange game. The only winning move is not to play.
In terms of its history, the earliest instances of mass-produced rockets would be the V-2 rockets in Europe during World War II, which the Nazis controlling Europe developed towards the end of the war and were used to bomb England. The V-2 has the awful distinction of being the only weapon system to have cost more lives in its manufacturing than its use in the battlefield, due to the conditions and the slave labor used in its production, and the complete disregard of workers' safety and well-being in the manufacturing process. Once the war ended, a lot of German rocketry expertise was transferred to the United States through Operation Paperclip, and the Soviet Union on their part had a similar program where they would offer asylum in exchange for expertise to German scientists. The Union of Soviet Socialist Republics kept pace with the West in terms of rocketry development, launching the first human satellite with Sputnik, and in the following year the United States launched its own first satellite into orbit, marking the start of a new era, the space race. These are the first instances of human-made objects launched into space in ballistic trajectory through the use of science and engineering. Rocketry will continue to develop with the Cold War, eventually leading to intercontinental ballistic missiles, or ICBMs, capable of touching down anywhere on Earth with their nuclear weapons. The 50s and the 60s were filled with both Soviet and American missions into space, each nation pouring resources into a space program as a way to establish dominance over the other. Both nations managed to send unmanned probes to touch down the surface of the moon in the 60s, and eventually managing to get return missions bringing samples back to Earth from the moon's surface, building the institutional knowledge that both space programs would need to launch larger, more ambitious missions with heavier payloads and larger rockets, and spending longer in space and going further from Earth. And finally, the space race culminated in 1969, when the world for the first time saw live images of a person from Earth walking on the surface of the moon.
20 feet down, 2.5, picking up some dust. 30 feet, 2.5 down, big shadow. 4 forward, drift into the right a little. 20, down a half. Contact light. Okay, engine stop. Houston, Tranquility Base here. The Eagle has landed. Roger, Tranquility, we copy you on the ground. You got a bunch of guys about to turn blue. We're breathing again. Thanks a lot. Okay, Neil, we can see you coming down the ladder now. I'm at the foot of the ladder. The LEM footpads are only impressed in the surface about 1 or 2 inches. I'm going to step off the LEM now. That's one small step for man, one giant leap for mankind.
In '69, NASA's Apollo 11 mission touched down on the Sea of Tranquility, marking the first extraterrestrial landing on behalf of humanity. The Apollo missions used the Saturn V rockets. The Saturn V is a retired super heavy lift launch vehicle used for the 9 Apollo missions, and also launching Skylab, the first American space station to orbit. Saturn V was designed by a controversial, notorious, early prominent figure in the NASA program, Wernher von Braun. The Saturn V stood 110 meters tall and it was 10 meters across, weighing almost 3 million kilograms, or 6.5 million pounds. For reference, SpaceX's Falcon Heavy stands at 70 meters and weighs half as much as the Saturn V, at 3 million pounds or 1.4 million kilograms. What is Artemis? So moving on to today and the main topic of this video, NASA's Artemis programs. The Artemis program, named after the twin sister of Apollo, who was the goddess of the hunt in Greek mythology. is a series of robotic and human missions led by United States National Aeronautic and Space Administration and its 3 partner agencies, the European Space Agency, Japanese Aerospace and Exploration Agency, and the Canadian Space Agency. The Artemis missions, if successful, would re-establish the first human presence on the moon since 1972, when Apollo 17 touched down last on the surface of the moon. The program's long-term goal seeks to establish a permanent base on the moon, which should serve as a launch pad for missions on Mars and an eventual human landing on the surface of the Red Planet. Additionally, the program will launch the Lunar Gateway space station into orbit around the moon,
and a place to return to when our work on the lunar surface is complete. We need a lunar home away from home. This will be the Gateway. Starting with the power and habitation modules, the Gateway will be the first long-term outpost in lunar orbit humans have ever had. Primed for new discoveries, this orbiting laboratory will provide us with a unique view of our solar system. And it's already becoming a beacon for the future of international and commercial cooperation in space. With increasing capability and longer missions over time, the Gateway will be a powerhouse of technology and science, paving the way for future human missions to Mars. Design and fabrication of Gateway elements by NASA and our international partners is well underway around the world right now. Wherever you are on planet Earth, today you are part of the Artemis generation. I'm NASA astronaut Randy Bresnik, and I invite you to join us by following NASA Gateway on social media and telling us where you call home.
The Artemis missions will also mark the first times a woman or a person of color landing on the surface of the moon, better representing all of humanity. On November 16, 2022, Artemis 1 was launched into orbit by NASA's Space Launch System rockets, SLS. Successfully entering orbit according to plan. The Artemis 2 mission will take place in 2024, followed by the Artemis 3, which will be a crewed lunar landing in 2025. Artemis 4 will be docking with the Lunar Gateway station in 2027, and potential yearly landings on the moon after that. From NASA's SLS systems to SpaceX's Falcon Heavy and Falcon 9 systems, also using SpaceX's Starship heavy lift rockets. The rockets are chosen due to the reusability costs and the mission parameters. The SLS and SpaceX's Starship being much larger and more expensive per launch. Most modern orbital or moon missions will use multistage rockets. Most multistage rockets are designed to use different engines in different phases of travel and under different atmospheric conditions. They're also designed to shed weight to increase efficiency throughout flight. This animation shows rockets shedding fuel tanks as they progress through their journey, increasing their efficiency by dropping dead weight. First, a rocket needs to take off from a resting position on the surface of the Earth, fly into the atmosphere, into low orbit, generally flying eastward. Once approaching low orbit, rockets will shed their Phase 1 rocket boosters, and then once in orbit, you will have to have another burn to go into a transfer orbit from when you're in the Earth's gravity well and then falling into the moon's gravity well, and then entering orbit around the moon. Once a stable orbit around the moon, a lunar landing can be attempted. In the Apollo missions, a smaller capsule went down to the surface of the moon, and larger vessels stayed in orbit. The lunar lander later re-entering orbit and meeting up with the main capsule. This is done for efficiency since less mass is used, less fuel is used, allowing for a smaller vehicle. The vast majority of the energy of a rocket will be burned in the very first parts of its flight when it's closest to the surface of the Earth. This is due to the effects of gravity and air resistance. Air resistance is greatest at lower altitude. It takes far more energy and much larger rockets to get off the surface of the Earth, to get off of a body with a lower gravitational field like the moon. And additionally, the moon has no atmosphere to present any resistance. This is why a lot of times in science fiction you'll see the portrayal of a space elevator. A space elevator would completely remove the need for the first stage rockets, which are the most expensive and the largest, by allowing launches from low orbit where there's minimal air resistance and you already have diminished effects of gravity, allowing for much cheaper launches. So in the case of a space elevator, you would be using the mechanical energy of a lift or an elevator as opposed to the chemical energy as a reaction between an oxidizing agent and fuel. Although if it's ever feasible to build a space elevator is a question for a different century. Another common practice is launching as close to the equator as possible. The closer you are to the equator, the greater the effect you get that I mentioned about flying eastward. So the most efficient possible point to launch into orbit from will be from the equator heading east. The least efficient will be on the pole heading west. Can't really have west at the poles though, but yeah, you get the idea. At the equator, you are at the maximum possible angle distance from the axis of rotation from the Earth at 90 degrees, since the rotation of the Earth is around the poles. That's why the American space program, NASA, launches usually from Florida, Texas, or Mississippi. The Soviets and the Russian space program launches from bases to their south from Kazakhstan. Also, another reason rockets are used for orbital and space missions as opposed to cannons is the rate at which it applies the kinetic energy to the capsule or the vessel that's traveling. Since rockets carry their fuel on them, they're able to gradually expel exhaust, controlling their velocity very precisely and gradually over the time of flight. A cannon applies all its kinetic energy to the projectile at the very beginning of flight, meaning you have one moment of very high kinetic energy being transferred to the capsule or the projectile. Such a high kinetic energy would, one, kill anybody on board, and two, destroy the capsule with the kinetic energies needed to escape Earth orbit from a single blast or one shot from a cannon. Cannons apply all their kinetic energy at the beginning of the flight, as opposed to gradually. In 1800s literature, Jules Verne describes a mission to the moon in his novel From the Earth to the Moon. He tells us the story of the Baltimore Gun Club, a post-American Civil War society of gun enthusiasts, and their attempts to build a giant cannon to launch a 3-person mission to the moon. They propose using a cannon to launch people to the moon, and since the cannon applies all its kinetic energy, initially it wouldn't be feasible, meaning that to escape the orbit of the Earth with a cannon, you would have to achieve velocities that cannot be achieved even with modern artillery. For reference, modern artillery shells leave a cannon traveling about 1 kilometer a second, or about 3 to 3,500 feet per second, which is only high enough to reach about 4 kilometers off the surface of the Earth, or about 2.4 miles of altitude. The moon is nearly 400 kilometers away, or 2,038,000 miles. You would need orders of magnitude greater in terms of energy to achieve orbit than a cannon or artillery can deliver to a projectile. A rocket, since it has its fuel on board and can apply thrust gradually over time as opposed to all at once, it can travel at a lower speed initially in order to try to make stuff more efficient. Interestingly, rocketry has always been a very closely guarded government secret, because of its implications in its use with nuclear weapons. If you need to deliver a nuclear payload to the other side of the Earth, the best way you can go about it is using a rocket. In this case, usually referred to as an ICBM, or an intercontinental ballistic missile. So that's why working for an aerospace company or a company involved in rocketry or satellite delivery will generally require more background checks and clearances for employment. Okay, so going over the Artemis missions real quick. The Artemis 1 mission launched on November 16th of 2022, putting 3 mannequins into orbit around the moon. Artemis 2 will be a 4-person lunar flyby. Artemis 3 will deliver 2 people to a lunar landing on the moon for the first time since 1969. Artemis 4 in 2027 will deliver the Lunar Gateway station to orbit around the moon. Artemis 5 will be a lunar landing delivering the Gateway airlock module. Artemis 7 through 11 are planned for the 2030s and consist mostly of lunar logistical missions, delivering equipment to the moon base. All the main Artemis missions will use the SLS rockets that NASA developed. The support and refueling missions will use SpaceX and other commercial vehicles, such as the SpaceX Falcon Heavy and the Falcon 9, or the Vulcan Centaur developed by the United Launch Alliance. The Lunar Gateway is a small space station that's being planned to be put into lunar orbit, and it's going to serve as a storage hub for astronauts, robots, and rovers. It's going to be the first space station outside of low orbit and the first space station in orbit around the moon. Rebuilding of institutional knowledge. So one of the reasons that NASA is taking the step-by-step approach to their lunar and hopefully eventually Mars missions is that they have to rebuild institutional knowledge. Anybody involved with the Apollo missions that has practical experience with such complicated space missions, such as a lunar landing, has long since retired. So NASA needs to rebuild its institutional experience and knowledge in performing these more complicated outer space missions to make sure that it has the right procedures, right qualifications, and maintenance procedures for its equipment, the right personnel, and the right teams in the right places, so that a mission with so many different moving parts can go smooth. And they have to get it right every time on the first try. NASA's not the only space agency with its eyes on the moon. If we are to enter another space race, NASA's main competition will come from the Chinese space program called the China National Space Administration.
Mars rover, a space station, and a lunar probe. China's space program is in overdrive. In 2021 alone, it sent 3 astronauts to the Tiangong space station, a rover to Mars, and an orbiter that circles the red planet. In 2019, it launched 89 payloads with 39 rocket launches. But what's behind its space aspirations and recent rapid advances?
China has developed extremely quickly in the 20th century, economically and technologically, under the iron fist of the Chinese Communist Party. Chinese society and culture has over 5,000 years of uninterrupted history, making it one of the oldest continuous civilizations on Earth. And China is poised to be a major player in this next century. In terms of geopolitics, China, like the United States, is a vast country with many different cultural and linguistical groups that claim an identity. Hundreds of different linguistical dialects. Chinese is not a language, but rather a family of languages that share a common writing and history. Modern China, under President for Life Xi Jinping, has taken a much more assertive and aggressive posture in terms of portraying its military and economic might abroad. And part of that mandate is ensuring that China stays competitive in space. Chinese space capabilities have expanded extremely fast, relying on a robust and very well developed academic and scientific infrastructure throughout their nation. In 2000, China started building its own satellite constellation so as to not rely on GPS, since the Global Positioning Satellite System is US created and run by the US military, and eventually was allowed to be used for the civilian market for free, but it remains an American military satellite constellation, which China wants to be independent of. In 2003, China became the 3rd nation in the world capable of independent human spaceflight, when astronaut Yang Liwei was in orbit for 21 hours. 2007, China was able to put its first orbiter in orbit around the moon. 2008, China carried out its first extravehicular activity, EVA, or a spacewalk. And then 3 years later, China was able to launch its first orbital station, the Tiangong-1. Personally, I think that one of the most interesting recent efforts in space by China, the landing of the Chang'e 4 lunar rover on the far side of the moon, also known as the dark side of the moon. If your nation is looking to make waves in space travel and not just own first in history, landing on the far side of the moon would be a logical step. Landing the U-2 rover in the von Karman crater. And while this is very fertile grounds for a lot of conspiracy theories about their intentions on the far side of the moon, the rover is known to carry geological survey tools. Besides, there's only so much you can do with limited payload sizes. More than likely, the spot was chosen for propaganda reasons or for marketing reasons. And in recent years, China continues on its preparations for eventually launching its own manned lunar mission. It's also important to recognize the other international players in space. There are dozens of other space agencies and programs that launch their own rockets or operate their own satellites in space, even if they have other nations actually launch their satellites. Nigeria, Brazil, Indonesia, India, and many more have their own independent space programs, ensuring their interest in space, and also working with the nation's communications, weather, and geopositioning satellites. Even NPR's economic podcast, Planet Money, has their own satellite in space. Just want to say, I love you, NPR. I love you, Planet Money. The Indian Space Agency The Indian Space Research Organization has quickly developed a reputation for its efficiency and practicality, for being a very resourceful and cost-efficient organization. In 2008, the ISRO launched the Chandrayaan-1 and 2. That might have been one of the first probes to detect water on the surface of Mars. The ISRO also launched its first lunar rover in 2013. From Central America, I'm Costa Rican born, Honduran raised. I want to give a shout out to the first Central American astronaut, Franklin Chan Diaz. He's an MIT PhD graduate in plasma physics, and in 1918 became the first Central American astronaut into orbit with NASA. He's currently CEO of Ad Astra Rocket Company, which he founded, and is adjunct professor at Rice University. So why all the focus in space? Why does the space race matter? Looking up to the sky, the experience of curiosity and wonder and the desire for exploration is universally human. It belongs to all nations and all people, along with the other universal sentiments and feelings such as love, pain, grief, and joy. It is the most natural human instinct to explore the world and the solar system that we're in. It gives our brightest engineers and our brightest scientists the opportunity to work on the challenge of a lifetime, to develop new technologies, new methodologies that will eventually make its way into the civilian market. The aerospace industry provides hundreds of thousands of quality, high-paying jobs and is considered to be a boost for the national economy. And then along that, all the support services and companies, vendors, and contractors that provide services to the aerospace industry, thus creating more indirect jobs. This scientific collaboration will expand out to the nation's universities and academic programs, creating liaisons that can create a pipeline from young minds into space exploration, inspiring bright, curious people for many generations to come. While there are many different nations competing currently in space, the achievements that they accomplish belong to all of humanity. With the Artemis program also comes the Artemis Accords. The Artemis Accords are a series of agreement with partner nations trying to establish a common framework for responsible operation in space, collaboration, and interoperability. The goal is to prevent any potential conflict in space in the future. Cooperation in space endeavors among its signatory nations. The Accords call for a commitment to transparency, responsible space travel, and scientific exchanges, and their commitment to peaceful space exploration. Although to note, most of the major players in space have not signed on to the Artemis Accords. It's also important to remember that space exploration is a very dangerous business, and a lot of lives have been lost. 31 people are counted to have lost their lives in association with the missions from one of the major space agencies. We should remember their bravery as a new generation of astronauts continue to go up in space, and we must do everything we can so that they're safe as they carry out their task of exploration on behalf of all of humanity. So that's my video on rocketry and the basics of space exploration, why the Artemis missions matter, and humanity's efforts to go back to the moon and beyond. Hopefully within our lifetimes, we will see the first human landing on an extraterrestrial planet of Mars, possibly within the next decade or two. I think that will be a very exciting moment for everybody on Earth. Thank you very much for watching. Like and subscribe and all that if you like it. Take care of yourself. Bye.